Prove using vectors, the vertices of a parallelogram can be formed by connecting the midpoints of the opposite sides of a quadrilateral and the midpoints of its diagonals. Okay, let's try to understand it graphically. So let's consider a quadrilateral with vertices A, B, C, and D. Now, we consider the side AB, and let's say E corresponds to the midpoint of AB. Then we consider the side opposite to that of AB, so that's DC. So here we'll be considering another midpoint. So let's say F is the midpoint of the side DC. Now, we'll join the diagonals of the quadrilateral. That means we'll join the vertex A and vertex C, and vertex B and vertex D. Now, we will be considering the midpoints on the diagonals BD and AC. So let's say we have the diagonals AC. Then let's say G is the midpoint of side AC. Then we have BD. We'll suppose that H is the midpoint of the diagonal BD. We'll join E, G, F, and H, and that's going to give us another quadrilateral. So our goal will be to show that E, G, F, H, this quadrilateral is actually a parallelogram. Okay, so what we'll do, we'll first consider some origin O. This is going to be an origin or some coordinate system. With respect to this origin, we're going to suppose that the position vector of the vertex A be denoted by A vector. Position vector of vertex B will be B vector. Position vector of vertex C will be C vector. And position vector of vertex D will be D vector. Now, with respect to these four position vector A, B, C, D, we can define the position vector of E, G, F, H. Let's start with the point E. So here E is a point that is the midpoint of AB. So we can say here that this point E divides the side AB in the ratio 1:1 internally. So that means here we can apply the internal section formula such that we get OE vector. This will be given by A vector plus B vector divided by 2. Similarly, we can find out the position vector of F, because F is going to be the midpoint of CD, or in other words, F divides CD into ratio 1:1. Similarly, we can say that OF vector, so that's going to be equals to C vector plus D vector divided by 2. Then we have OG vector. So OG vector is going to be, since G is the midpoint of AC, so here the position vector of OG will be A vector plus C vector over 2. And H is going to be the midpoint of BD. So we have OH vector. That's given by B vector plus D vector divided by 2. Okay. Now, what we'll do, we will take, let's say, point E and point H and consider it to be a vector going from E to H. So now, what is our vector? EH. So EH vector, so that's given by OH vector minus OE vector. So what is OH vector here? We have B vector plus D vector divided by 2 minus OE vector. So that's A vector plus B vector divided by 2. So when it's subtracted, we are going to get D minus A divided by 2. And we will try to find out the vector GF going from G to F. So GF vector, so that's going to be OF vector minus OG vector. So OF vector is C vector plus D vector over 2 minus OG vector. So OG vector, that's going to be A vector plus C vector divided by 2. When you subtract it, we're going to get D vector minus A vector over 2. Now clearly we see that EH vector equals GF vector. Now in a quadrilateral, if the opposite side are parallel because they are collinear and also they are of equal length, so we can say that EGFH is a parallelogram. So this means that this implies that EGFH is a parallelogram. So we have successfully proved our problem.